Welcome, space enthusiasts and curious minds. Today, we're diving into a groundbreaking discovery that's shaking the foundations of our understanding of the universe. The James Webb Space Telescope, humanity's most powerful eye in the sky, has spotted something utterly perplexing near the dawn of time itself. Stay tuned as we unravel this cosmic mystery, and no one expected this. Situated an astounding million miles from Earth, the James Webb Space Telescope is unveiling a universe more intricate and baffling than astronomers had ever anticipated. This vast cosmic landscape, largely obscured by interstellar dust, is being brought into clearer view thanks to the unparalleled capabilities of this monumental space observatory. James Webb excels in this task by detecting infrared light, a type of light with lower energy than what our eyes can perceive. This light, adept at weaving through cosmic dust, is captured effectively by the telescope's massive 21-foot wide mirror. This allows it to gather light from some of the universe's most remote entities. Remarkably, wherever the James Webb Telescope has been directed, even during brief preliminary image captures lasting mere seconds, it has consistently revealed galaxies in the backdrop that weren't even the initial focus of observation. This indicates that the James Webb Telescope is guiding us on an exploratory voyage into uncharted cosmic territories, equipped with a novel vision. The telescope's exceptionally sharp vision, when trained on distant and ancient regions of the universe, has uncovered startling phenomena near the universe's inception. These findings have left astronomers in awe, confronting the existence of cosmic monsters in Webb's images that challenge our current understanding and potentially reshape our cosmic theories. Join us as we delve into the ways in which the James Webb Space Telescope is revealing aspects of the universe that even astound seasoned scientists. It's essential to understand the purpose behind the creation of this remarkable observatory. While Earthbound astronomers typically position their telescopes atop mountains or in secluded deserts to minimize atmospheric interference, these locations still don't offer a completely unobstructed view of the cosmos. This is where space, the ultimate vantage point, comes into play. Launched in December 2021 as the successor to the Hubble Space Telescope, James Webb marks a significant advancement in space observation technology. Its large golden mirrors and sophisticated infrared cameras enable it to observe exoplanets orbiting stars beyond our solar system with unprecedented clarity. However, for our current exploration, what's most pivotal is James Webb's ability to look back further in time than its predecessor, Hubble.in astronomy. The greater the distance an object is from a telescope, the older it appears in the telescope's view. This is because light takes time to travel such immense distances. The light that James Webb captures includes some of the most ancient light in the universe, dating back to a mere 100 to 250 million years after the Big Bang. This period is the relative infancy of our universe, offering a glimpse into its earliest days. The light that the James Webb Space Telescope captures from the farthest reaches of the universe is astonishingly ancient, having embarked on its journey nearly 13.77 billion years ago. This duration is almost as old as the universe itself. As Webb focuses on a specific area of the sky, it essentially looks back through time. The objects furthest away in its images are the oldest, while those closer to the foreground are more recent. These images, rich in cosmic history, are known as deep field observations. To the naked eye, they may appear two-dimensional, but to scientists, they represent a timeline of the universe's evolution. Before the era of James Webb, the Hubble Space Telescope provided humanity with its most profound insight into cosmic development. In Hubble's images, a clear pattern emerged. As astronomers looked further back in time, they observed fewer galaxies, and these galaxies were smaller. This observation aligns intuitively with what we understand about evolution. Just as the oldest layers of Earth's crust hold more primitive forms of life, the oldest galaxies in a deep field image are thought to be more rudimentary. These ancient galaxies differ from their modern counterparts in that they had less time to form and develop. They are akin to teenagers compared to the fully matured adult galaxies we see in the current universe. With the advent of the James Webb Space Telescope, astronomers were keen to extend this glimpse even further back in time. As astronomers looked further into the past with the James Webb Space Telescope, they expected to see a continuation of the pattern observed in the Hubble images. The assumption was that there might be a few more distant galaxies, but they would be exceedingly rare. However, the reality defied these expectations. When James Webb began its operations, it quickly became clear that the early universe was far more illuminated and populated with galaxies than previously thought. Caitlin Casey, an astronomer at the University of Texas, Austin, expressed surprise at the abundance of activity detected from that era. The astonishment was widespread among the astronomical community. For instance, Mike Boda, another University of Texas Austin astronomer, recalls his disbelief, remarking, "This just can't be right." To the untrained eye, the images from James Webb might just look like indistinct red smudges among other shapes. Yet, to experts like Boda, these smudges posed a significant challenge to the established narrative of the universe's early years. The observations pointed to a time, over 12 billion years ago, when the universe transitioned from a dark, gas-filled expanse to a bright realm teeming with stars and galaxies. This pivotal era set the stage for all subsequent cosmic developments, including the formation of our solar system. The James Webb Space Telescope's findings are reshaping our understanding of these formative years in the universe's history. Before the advent of the James Webb Space Telescope, scientists had formulated several theories about the critical early phase of the universe. With James Webb's breakthrough, observations of previously unseen cosmic regions, these theories are now being rigorously tested. While the galaxies observed by Webb may seem like vague blobs to the casual observer, scientists can analyze the light they emit to deduce their size and age. Surprisingly, early analyses indicated that many of these galaxies were not just nascent formations, but rather they were already mature and sizable, akin to full-grown adults rather than adolescents. Caitlin Casey, an astronomer, likens this revelation to finding evidence of advanced life forms in geological layers where only primitive life should exist. In a more whimsical analogy, Casey describes it as discovering that the universe was having a grand celebration in its earliest times, a party of which we were completely unaware. You might wonder, so what's the big deal about finding large, bright, and abundant galaxies near the dawn of time? While this discovery might not seem to contravene the laws of physics, the real conundrum lies in the element of time. As Casey points out, these findings are pushing the boundaries of what we understand about the universe's age. The galaxies we're observing had remarkably little time to form and reach their mature states, given the universe's age. This poses a significant puzzle for astronomers and challenges our current understanding of cosmic history and development. The scenario presented by the James Webb Space Telescope's findings is akin to flipping through a family photo album and realizing that your grandmother transformed from an infant to an adult in just a few months. This analogy highlights the puzzlement astronomers face. It's as if we're missing a crucial piece of the puzzle in understanding either human development or, in this case, the development of galaxies. If these early galaxies indeed contain the number of stars suggested by initial observations, their existence seems almost implausible. For such a galaxy to form, it would require a complete conversion of all its gas into stars, a phenomenon that is virtually unseen anywhere in the universe. Typically, in star-forming galaxies, there's always some gas left over. Gas is a fundamental ingredient in star formation, but it's never entirely used up. This is what makes the James Webb observations so perplexing. They appear to contradict what we know about galactic formation and development. So what could possibly explain the existence of these bright, large galaxies observed so early in the universe's history? The straightforward answer is that scientists don't yet have an explanation. As Caitlin Casey remarks, the past year of analyzing data from the James Webb Space Telescope has been astonishing. the telescope has revealed numerous extraordinary phenomena in the early universe. This is precisely why many scientists are astounded. These findings challenge our current understanding and prompt a reevaluation of our cosmic theories. Perched a million miles from Earth, the James Webb Space Telescope unveils a universe far more intricate and confounding than astronomers had ever envisioned. Hidden largely behind cosmic dust, this vast celestial realm is being probed by James Webb, the largest space telescope in history. It captures infrared light, less energetic than visible light, which can more easily penetrate cosmic dust. Its impressive 21-foot wide mirror gathers this light from some of the universe's most remote objects. As a result, no matter where it points, James Webb unexpectedly reveals distant galaxies in the background, taking us on a journey into the unknown. When focusing on the distant and ancient cosmos, Webb has uncovered bewildering phenomena from near the universe's inception, causing astronomers' jaws to drop. These findings challenge our understanding of cosmic history. The James Webb Space Telescope was designed to overcome Earth-based observational limits. Launched as Hubble's successor, it boasts large golden mirrors and infrared cameras for superior observations. Its capacity to observe further back in time than Hubble has been particularly pivotal. It captures light nearly as old as the universe, dating back to 250 million years after the Big Bang. When Webb trains its mirrors on a patch of sky, it peers through time. The images it captures, called deep field observations, show a progression from ancient to more recent galaxies. Previously, the Hubble Space Telescope provided the deepest insight into space evolution. Hubble's images showed a pattern of fewer, smaller galaxies as we looked further back in time, similar to more primitive forms of life found in the oldest layers of Earth's crust. However, James Webb's observations disrupted this pattern. Instead of sparse and small early galaxies, Webb revealed unexpectedly large and mature galaxies. Caitlin Casey, an astronomer, likens this to finding advanced life forms in Earth's earliest layers or discovering a grand, unknown cosmic party in the universe's infancy. These large, bright galaxies near the universe's beginning defy our expectations and understanding of cosmic time. As Casey points out, these galaxies challenge the limits of the universe's age, having had little time to form. This anomaly is akin to finding out your grandmother matured from an infant to an adult in just months, suggesting we might be missing a significant piece of the cosmic development puzzle. The existence of these galaxies, given their implied star count, seems nearly impossible. Typically, star formation leaves excess gas, but these observations suggest an unprecedented efficiency in converting gas to stars, defying known cosmic patterns. These baffling observations by James Webb have left scientists astounded, as Casey notes, revealing wild phenomena in the early universe. If these findings are accurate, they could prompt a radical rethinking of cosmological knowledge. History has seen such paradigm shifts before. Vera Rubin's observations in the 1960s and 70s led to the discovery of dark matter, and Albert Einstein's reinterpretation of gravity in the 20th century stemmed from anomalies in Mercury's orbit. These moments of disbelief often pave the way for profound new insights or expose vast areas of unknowns in science. While most astronomers believe something unusual is at play, the exact nature and implications of these findings remain an exhilarating mystery, potentially heralding a significant leap in our understanding of the universe. Regarding these intriguing galaxies observed by the James Webb Space Telescope, it's important to approach the findings with caution. As noted by Christina Williams, an astronomer at Noirlab, the data we currently have is still preliminary. The scope of James Webb's observations, although groundbreaking, has only covered a minuscule fraction of the universe. So far, the telescope is focused on relatively small areas of the sky. There's a possibility that the initial excitement surrounding these galaxies could wane with further study and more comprehensive observations. However, If these findings are confirmed, scientists will face the challenge of understanding why these galaxies exist in their observed state. As the scientific community grapples with this question, several theories are being considered, ranging from minor adjustments to our current understanding to what Mike Boda calls the most disruptive options. One of the thrilling aspects of these discoveries is that each theory represents a different pathway, leading to new questions, possibilities, and insights into both our scientific methods and the nature of the universe. One possibility, for instance, is that stars and galaxies formed differently, perhaps more efficiently, in the early universe. Casey points out that the early universe was a much darker place compared to now, with fewer stars and galaxies. This lack of light could have influenced how stars formed from new gas clouds, potentially leading to different developmental processes than what we observe in the present-day universe. In the early universe, the absence of widespread starlight, akin to a lack of floodlights, might have facilitated the rapid formation of stars in a way that isn't possible today. Currently, the universe is much more illuminated, and this pervasive starlight can actually hinder the development of new stars. Mike Boda suggests that this slowdown in star formation may not have occurred in the early universe, possibly leading to the creation of these massive galaxies. However, the specifics of this process remain unclear. If this theory holds true, it would be surprising, but it wouldn't necessitate a complete overhaul of our current understanding of galaxy formation and cosmology. A second possibility involves a different source for the brightness observed in these galaxies. Casey points out an alternative and equally perplexing explanation. Instead of a vast number of stars, the brightness might be due to some of the most massive supermassive black holes. This scenario is complex because, while James Webb is observing galaxies, the light perceived might not be emanating from stars. An alternative source could be a very hot disk of material being drawn into a gigantic black hole. The intense heat of this accretion disk could be so extreme that it emits the significant light observed by the telescope. This scenario presents a different angle to the puzzle, shifting the focus from star formation to the activities surrounding supermassive black holes in the early universe. These incredibly bright sources of light can even surpass the entire galaxy in which they reside in terms of luminosity. This explanation does offer some solutions to certain challenges. According to Aaron E. Lambrides, an astrophysicist involved in ANASA fellowship, assuming that all the mass within these galaxies is attributed to black holes, results in more reasonable stellar masses. This avoids the need to account for excessively efficient star formation processes, preventing an upheaval of our understanding of the universe. However, this solution, while intriguing, introduces a new set of perplexing questions that could potentially challenge our comprehension of the universe in different ways. One such question pertains to the abundance of supermassive black holes in the early universe. Scientists acknowledge that supermassive black holes play a role in galaxy development, but if these Webb observations do indeed represent black holes, it would significantly deviate from our expectations regarding the number of powerful supermassive black holes that should exist at this stage in cosmic history. The rapid growth of these black holes remains a puzzle, and the fundamental issue is that these observations don't align with our pre-existing theories, leading scientists to suspect that there may be gaps in our current understanding of the universe. Option 3 presents the most far-reaching possibility. Scientists may be overlooking a significant component in their understanding of cosmology. Cosmology serves as a combination of a recipe and a narrative for explaining the creation of the universe as we perceive it today. In this field, scientists begin with the earliest available observations, which capture the afterglow of the Big Bang, representing a universe before the existence of stars. They then employ their knowledge of fundamental properties of the universe, such as gravity and electromagnetism, to construct a narrative describing how the universe evolved into its current state. Welcome to Blasovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blisovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe. Live Q and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blisovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.